Hello everyone. Today we will continue with the topic of acceleration of mechanism, that is the graphical method. We will do another question on this topic. I'll just read out the question. A mechanism of a crank and slotted lever quick return motion is shown in figure. If the crank rotates counterclockwise at 120 rpm, determine for the configuration shown the velocity and acceleration of the ram d. Also determine the angular acceleration of the slotted lever. We will go through the question in detail. In this particular mechanism, it is basically a 6-link mechanism. You have link OA, which is the fixed link. Then you have link AB, which is the link number 2. And then you have link OC, which is link number 3. And then you have a slider at B, which is link number 4. And then you have link CD, which is link number 5. And then you have another slider which slides along the horizontal, which is link number 6. If you consider each kinematic pair, if you consider the pair 1, 3, it is a turning pair. Similarly, if you consider pair 1, 2, it is also a turning pair. And if you consider link 3, 4, which is a sliding pair, and 2, 4, which is the same point, that is also a turning pair. And then you have C, which is the pair 3, 5, which is also a turning pair, and 5, 6 is also 5, 6 is also a turning pair. And then you have 6, 1, which is a sliding pair. This is a crank and slotted lever quick return motion mechanism. In this mechanism, AB is the crank, OC is the slotted lever, that is a slot will be in the lever, and inside the slot you have the slider B, which will move. Okay, slider will move to and fro as well as it rotates. Okay, so that is the type of motion of the slider. And then you have this is another slider which will move along the horizontal. Okay, so that is how this mechanism will work. Till now, whatever mechanisms we have studied or we have gone through, if you consider any point in a mechanism, if you consider any point on a link in a mechanism, that point or that link will have a relative motion with respect to a single point. That is how it will be. But in this particular mechanism, if you consider one particular link, that is the slider B, this slider B, if you closely watch, it will have a relative motion with respect to point A, which is nothing but a rotational motion, because it is the crank. AB is the crank. Also, slider B will have a relative motion relative to point O, which is also a relative motion, which is also a rotational motion, and also the slider B has a sliding motion along link OC. That means when you draw the velocity diagram, the velocity diagram should incorporate all these three motions of the slider in the velocity diagram. So how to incorporate these three relative motion of slider? By the conventional method, it will be little bit difficult. So what we do is, so to make things easier for us, what we do is, we will consider or we will assume that at point B or coincident to point B, there is another point B prime, and we assume that B is attached to the link AB and B prime is attached to the link OC. Okay, so that is how we will assume. Now it will be easier for us to incorporate the three motions of the slider in the velocity diagram. How we are going to incorporate that we will see when we draw the velocity diagram. So this assumption will make our work easier. Now this assumption is the only thing that is different from the procedure that we had followed from the previous question. The rest all are going to be the same process. As in the question, we know that AB is the crank, which is the driving link. So to start off the velocity diagram, first we need to find the linear velocity of point B relative to A. That is found out by the formula V equal to R omega, where V is the velocity of point B relative to the fixed point A, and R is the distance of the link AB, and then omega is the angular velocity of the link or the crank AB. In the question, instead of giving angular velocity, the angular speed is given. You need to convert the angular speed to angular velocity. That is, you need to multiply by 2 pi by 60, and all the units has to be in SI system. Thereby you will get the velocity of point B relative to as A as 1.88 meter per second. Now what you do is, to draw the velocity diagram, first you need to locate the fixed point. Here the fixed point is AO, so that has to be located somewhere near to the space diagram. And in the question it is given that the crank is rotating in the anti-clockwise direction. So this is the direction of rotation of the crank. That means the direction of velocity of B relative to A will be perpendicular to link AB and in the downward direction, because the crank is rotating in the anti-clockwise direction. So this is the direction of the linear velocity of B relative to A. Now you have the direction, you have found out the magnitude. Now what you have to do is, from the fixed point OA, you have to draw a line parallel to this direction. Okay, and the length of this line, that is length of the line AB, will be the magnitude of the velocity, and then you label it as I have done here. Now as per our assumption, we have assumed that B prime is a point coincident with point B but lies on link OC. That means now we need to consider the velocity of point B prime relative to O. Regarding that velocity, we don't know the magnitude. Only thing that we know is the direction of velocity will be perpendicular to the link. The direction of velocity of B prime relative to O will be perpendicular to the link, and in this case the direction will be perpendicular downwards. So what you do is, from B prime you draw a line perpendicular to OC downwards. So this direction indicates the direction of velocity of B prime relative to O. Why it is downwards? If you have any doubt, it is because the crank is rotating in the anti-clockwise direction. So when the crank rotates in the anti-clockwise direction, link OC will also rotate in the anti-clockwise direction. In that case, the linear velocity of B prime relative to O will be along the downward direction. So now regarding the velocity of B prime relative to O, you have now the direction. So what you do is, you have now O here in the velocity diagram. From O you draw a line parallel to this direction in the downward direction. Okay, since you don't know the magnitude of the velocity, that means you don't know the length, you know only the direction. That is what I have done here. Now regarding the slider B, as we had discussed, slider B has three types of motion or three relative motion. That is, it has got a rotational motion relative to point A, it has got rotational motion relative to point O, and it has a sliding motion along link OC. Out of these three motions, we have now incorporated two rotational motion, that is rotation about A and rotation about O. That is, we have represented the velocity of B relative to A and O, and these two motions are rotational. Now we need to incorporate the third motion, that is the translation motion along link OC. That is, here we will be representing it in the velocity diagram as the motion of B relative to B prime. Okay, for that, what you have to do is, from B in the velocity diagram, you have to draw a line parallel to line OC, okay, such that this line will intersect the line from OA, and that point will be B prime. Okay, so that is what I have drawn it here. Okay, so that represents, this will represent this line, that is the line B prime will represent the relative velocity of point B relative to B prime. That will be the translational motion, and then you have the vector O B prime, which will give you the velocity of B prime with respect to O, and then you have line A B, which indicates the velocity of B relative to A. So this velocity diagram actually represents all the three motions of point B. Okay, now in the mechanism we can see that C is a point on OB prime extended. Okay, but the reason why I am saying B prime is because we assume that B prime is lying on link OC. Okay, so don't get confused in that way. So the point on OC is B prime. Okay, so C is a point on OB prime extended. Similarly, in the velocity diagram also, point C will lie on the line joining O and B prime extended. Okay, so you have to locate point C on this line. Okay, how to do it, we will do it, we can see after some time. Okay, before that we will do an easier thing, that is to represent the velocity of point D, which is the slider, with respect to the fixed point. As we know that the slider will move only along the horizontal, and its motion will be with respect to the fixed point. So what you do is, from the fixed point OA in the velocity diagram, you draw a horizontal line. Okay, so if you want, you can extend this line on either side of OA. Okay, so that is what I have done it here. Now we will locate point C in the velocity diagram. As we know, C lies on OB extended in the mechanism. Similarly, in the velocity diagram also, point C will lie on OB extended. The location will be decided by the law of proportion, that is, in the proportion in which C is located on the line OB prime. Similarly, C in the velocity diagram also, C will be located in the same proportion. Okay, for that I will just make a calculation. That is, this is not a formula, you can take in any way you want. On the left hand side you have the dimensions from the mechanism, and on the right hand side you have the dimensions from the velocity diagram. Only thing is that when you write this equation, there should be only one unknown. Okay, so based on that you get the distance on the velocity diagram, that is OC, as 2.33. Okay, so what you do is you take measurement of 2.33 on this line OB prime from point O. Okay, and that end point will be C. Okay, so that is how we locate point C. After locating C, now we have this link CD. You need to find the relative velocity or locate the relative velocity of C relative to D or D relative to C. In any way you can take. What you do is, from C you draw a line perpendicular to CD. Okay, from C, and that line actually indicates the line of action of velocity of C relative to D or D relative to C. In any way you can take. Regarding that velocity, we don't know the magnitude. Only thing that we know is the line of action. Okay, so what you do is, from C in the velocity diagram, you draw a line parallel to this line. Okay, that will meet the horizontal line from OA, and the meeting point will be D. This D should be in small letters. I have by mistake written in capital letter, that should be in small letter. Okay, so this indicates the velocity diagram of this mechanism. Okay, now in the question, as one of the question, we need to find the linear velocity of the slider or the ram D, which is what? The linear velocity of this ram will be the length of the line OAD. Okay, so this the length of this line will give you the velocity of the slider. Since we haven't used any scale factor, the distance that you get can be taken as it is. Also, if you want to have a bigger picture, then you can increase the scale. Okay, so sometimes this figure can be seen as a little bit smaller. So if you want to have a bigger picture, then you can increase the scale. Okay, you can double the scale. Okay, so the velocity of the ramp, you will get approximately 2.3 meter per second. Okay, so these values, you will get the results approximate